From the moment of the Big Bang, the universe has been on an extraordinary journey. Galaxies have formed, stars have ignited, and planets like ours have emerged. But what lies ahead for this vast cosmic expanse? Will the universe expand endlessly into a cold and empty void, pull back into a fiery collapse, or meet a fate as dramatic as the Big Rip? Throughout history, we've turned to mythology to make sense of the cosmos. The Norse imagined Yggdrasil, its roots and branches connecting all realms, a tree destined to survive even Ragnarok, the end of the world. The ancient Hindus envisioned cycles of creation and destruction, where the universe is born, grows, collapses, and is reborn in an eternal rhythm. Even the Greeks believed in a cosmos governed by cycles, with the phoenix rising anew from the ashes of its predecessor. Today, our understanding comes from the study of cosmic expansion, dark energy, and the mysterious forces shaping the fate of everything. Observations show that the universe is not just expanding, it's accelerating. Galaxies are racing away from one another faster than ever. What's driving this cosmic expansion? Enter the enigmatic dark energy, an invisible force making up roughly 70% of the universe, pushing galaxies apart. If dark energy remains constant, this acceleration will continue indefinitely. Stars will burn out, galaxies will fade, and the universe will grow colder, darker, and more desolate. An outcome known as the heat death, or the big freeze. Time will stretch endlessly, but there will be nothing left to measure it by. But what if gravity gains the upper hand? If dark energy weakens or reverses, the universe could stop expanding and begin to contract. Galaxies would collide and merge. Stars would explode in fiery cataclysms, and the cosmos would collapse into an unimaginably hot, dense point. A big crunch, a potential rebirth of everything. Then there's the most catastrophic scenario, the Big Rip. In this scenario, dark energy doesn't just remain constant, it grows stronger. At first, only galaxies are pulled apart. Then star systems unravel. Finally, atoms themselves are torn asunder, and the fabric of space-time shreds into nothingness. The universe wouldn't just end, it would be obliterated. Just as the Norse envisioned Yggdrasil enduring through cycles of death and rebirth, and ancient traditions imagined cosmic renewal, science reminds us that the universe's fate is still a profound mystery. Whether it's a quiet freeze, a fiery collapse, or a dramatic rip, each scenario leaves us in awe of the cosmos' vastness and our fleeting moment within it. Our current understanding comes from observing these cosmic epochs, each chapter marked by change. In the earliest moments, the universe was hot, dense, and rapidly inflating. Then came a cooling period where particles combined to form atoms, and light finally traveled freely, giving us the cosmic microwave background, a snapshot of the universe as it was over 13 billion years ago. To understand where the universe is headed, scientists rely on data from telescopes like the Hubble Space Telescope and more recently, the James Webb Space Telescope. They measure how light from distant galaxies shifts due to expansion, a phenomenon known as redshift. The farther away the galaxy, the more its light is stretched, offering clues about the rate of expansion. Galaxies aren't scattered randomly. They form a web-like pattern connected by vast filaments of gas and dark matter. This cosmic web helps us visualize the scaffolding of the universe. By studying its growth over billions of years, researchers can trace how expansion rates have changed and speculate on the influence of dark energy. These observations fuel models that predict three potential fates. If dark energy remains constant, we face the big freeze, a slow fading into darkness. If it reverses, we may experience the big crunch, an ultimate collapse. And if it intensifies, the big rip, where every structure, down to atoms, is pulled apart. Each outcome tells a different story about the ultimate destiny of everything we know. Ancient myths often describe the cosmos as cyclical, with creation followed by destruction, only to be reborn again. Modern science, in its own way, reflects this ancient theme. Some theories suggest that if the universe collapses, it could trigger another Big Bang. In this sense, the universe might be a phoenix, forever renewing itself. Regardless of the ending, one truth remains. We are observers in a universe of breathtaking scale and complexity. Our brief existence allows us to glimpse its grandeur and ponder its fate. Every star we see, every distant galaxy, every mysterious force at play, these are pieces of a puzzle so vast we can only marvel at the possibilities. The fate of the universe isn't just a question of endings. It's a window into how the cosmos has evolved. Each scenario, big freeze, big crunch, big rip, has unique consequences not just for galaxies, but for the very fabric of space and time. By exploring these possibilities, we're uncovering the story of how we got here and where everything might ultimately go. Consider the forces at play. Gravity, dark energy, and quantum mechanics each works on a scale that defies intuition. From the dense cores of neutron stars to the vast emptiness between galaxies, these forces set the stage for the universe's next act. We're not just bystanders, we're participants in a grand cosmic drama. In a big freeze scenario, the last stars will fade, leaving black holes as the dominant players in an ever colder universe. In a big crunch, galaxies would smash together, reigniting a cascade of star formation before everything condenses into a singular point. And in a big rip, every structure, stars, planets, even atoms, would be torn apart as space itself unravels. Our fascination with the stars isn't new. For thousands of years, we've looked up and wondered. The myths and stories our ancestors told weren't so different from the questions we ask now. What does the future hold? What becomes of the stars, the galaxies, and the very fabric of space? As we continue to unravel these mysteries, the ultimate fate of the universe reminds us how much we still have to learn. Perhaps one day we'll know for sure what lies ahead. Until then, the cosmos invites us to keep exploring, keep questioning, and keep dreaming.
Thank you very much, brother.